Hello to everybody in the crowd. Thank you for tuning in. I see the names of many of the students as well as other folks who are joining. So welcome everybody. Definitely appreciate you having you. This is the final energy speaker series of the quarter, and it's actually apropos. Water performs in cycles in a way, and our very first talk was with Dr. Hannah Kunkel, who talked about marine energy, and one of the main things was what are some of the implications around this and how does it relate to wildlife? So we're actually quite fortunate to have Dr. Robert Vadas with us today, who has basically dedicated his entire career to talking about or researching and figuring out and transmitting what are the implications for wildlife habitat, for estuarine and riparian zones as it relates to wildlife and fish, and has been with the Washington Department of Fish and Wildlife. So this is a really cool opportunity to learn holistically what are the implications of all these megawatts. We need to start moving in a direction where we're diversifying our energy. However, we also want to not think about it simply in terms of how much energy do we get, but what are the impacts on the whole system. So really looking forward to hearing how does policy drive that? How does research drive that? And what are some of the findings that we have both to protect some of these places and these populations, but also still move forward in our goals as a society in terms of what energy is provided. So with that, I'm going to hand it over to you, Dr. Vadas, so you can start ahead on what you have to share. So thank you so much for joining us.
You bet. Thank you. And thanks to Darren McGee for setting this up. Anyway, this is a project that started many years ago, and before I was involved, I've only been involved since mid 2018. But the and I'll mention some of the other players as time comes. I'm going to do something a little unusual, though. I'm starting with this title slide, which is a PowerPoint, but then I'm going to go to a PDF for a federal webinar course that came late in the Biden administration that I thought had some good graphics and stuff. So let me stop sharing for a second and hope I can get the other PDF up. Oh, one thing I should say before that, yeah, Bob's fine for me. I do want to present a little caveat that what I say doesn't necessarily represent my agency's policies. This is a project that is focused on the marine hydrokinetic, but I also talk about river hydrokinetic stuff, which is more stuff I'm dealing with American Fisheries Society, which is a separate hat. So please realize that that I'm going to try to wear two different hats in this presentation, um, and uh, and so that everybody's clear on that. All right. So anyway, let me stop sharing for a second. And try to get the other presentation up. Let's see. Okay. And
And we're good, just so you know.
good.
We got
Okay, great. Okay. Obviously, I'm not Dr. Hemery, but but this is a good little short presentation on marine energy, and and I will define that a little bit later, although it actually is kind of defined in this presentation as well. It has to do with basically underwater types of energy rather than offshore wind. But for now, oops, let's see. So now, one question I didn't ask is how to advance slides. Sorry. Do I just do it like,
if you go to the right side of that, you see
yeah,
1 and 12, that little arrow, that down arrow, if you click on that, it should, so very far right side of the screen,
yeah.
bottom right, there is an arrow that's a little down arrow. So where it says 1 of 12 on the very far right bar.
Oh boy, I'm not seeing that.
Um,
Yeah.
a simple scroll as well should do it. So if you're just scrolling downward,
Let's see if I can. It's not really going anywhere. Oh, there we
so
go.
yep,
All right, that
there you
should
go.
do it then. There we
Got
go.
it. Yep.
Okay. Yeah. All right, now we got it. Sorry, I'm not the most technically proficient, even though this I'm dealing with a very technical field here of marine energy, but oh well. So, so renewable energy, which does also technically actually marine renewable energy also does include offshore energy, whereas kinetic energy, hydrokinetic energy is what's underwater. There are five different types for marine and also one that's for larger rivers. I'll be talking more about these different types a little later, so we won't focus too much on them now. Um, but wind, of course, being above water, hydrokinetic below water. But as I also talked about, sometimes these projects can combine both. So for now, America is still in the very early stages. Of commercialization has been a lot tougher than it has been in Eurasia, where there's projects that have been underway for many years now and are actually viable. And seems like here in America that a lot of things get tested. There was one for the East River in New York City that looked like it was a go, and at the last minute they decommissioned. And it's like, so it's and a lot of the companies that have developed have either gone bankrupt or they've switched to other things like inland solar and wind power. So so it's this is an industry that is definitely hobbling along, trying to get some, get to a full steam position, and maybe someday we will have things that are commercially viable here in Washington. And I'll say more about what's happened here a little bit later. But anyway, you know, of course, we want to deal with the environmental concerns and make sure that these projects are viable. But if you make it so hard to do them, then basically implicitly what you're saying is we're okay with the present status quo, which is fossil fuel based. And even, as I'll mention a little later, even nuclear energy is not renewable. So, and and even though things like hydropower dams are considered renewable, they do have significant impacts, as I'll get into later. So we want to look at other alternatives and diversify, as Ted mentioned, diversify the energy portfolio. So anyway, solar and wind, of course, are the more popular forms and ones that are do tend to make it a lot easier commercially. But the Biden administration predicted that marine energy could become 1/5 of the American resource, and that's including both inland and which is river, and also the marine hydrokinetic energies. So the uh, the oceans have a lot of energy. Anybody who's swum there can certainly attest to that and get smacked around by waves and everything. So, um, and it's particularly at higher latitudes where you have a higher tidal range, um, faster currents, more, if you've ever spent time in the equator, the, the, it's a lot harder to do body surfing, for example, in the waves because they're not very big. So tends to be up farther north. Alaska in particular is good on the Pacific coast, but we have a lot of potential here in Washington too. Um, anyway, as well as the possibility of connecting to the macro grids. There's also the potential for what's called microgrids, and they're already being developed in Alaska, although they're still trying to get to a renewable stage with it, where they basically become kind of self-contained things and not having to depend on the macro grid, eh, which for them, people who are in remote areas like islands or on, maybe on the remote coast, they they're probably going to be the last priority when they're brown and blackout. So if they can be a little more self-sufficient, good for them. And hopefully, these microgrids become more, renewable as time permits. And certainly, on our outer coast, we do have more remote areas, around in the Olympic Peninsula where these microgrids might be a good idea. So anyway, this is just a map of some of uh, the potential energy resources. As you can see, both the east and west coasts have a lot of power potential, as does inland with the river hydrokinetic. Um, I already mentioned how Alaska is a really strong place for it. And even Hawaii, is very good. And there is a research station there that definitely deals with marine hydrokinetic energy. So anyway, just showing you, there's a few of the types of wave energy converters or WECs that are, I'm not going to go into that kind of detail for this talk. But we do have a report that does talk a little, or draft report that does talk a little more about what each of these does and how they work and all. But in general, with wave converters, they depend on bending. They bend with the waves, and therefore they need strong joints, and that's how they tend to work. The tidal turbines, a lot of times they work a lot like wind turbines or dam turbines in terms of spinning and producing energy that could be transferred elsewhere. And in the case, of course, with offshore projects, typically that's going to involve cabling back to the shore, although there's also been some ideas of turning off, instead of using cables, turning offshore power into hydrogen energy and shipping that back to shore. So there may be other alternatives besides cabling, but cabling is the most common way at this point. So these spin and create energy. There's a lot of different types, and then there's also even bigger turbines, which are called the ocean current turbines, which tend to be in very deeper areas where you can have bigger turbines, and they these tend to be in fast parts. It's not something that we're looking at here in Washington, because we don't have that type of deep, fast currents. But places like off Taiwan and in the Southern Gulf Stream in Florida are places where this might be viable and have been talked about and explored. So maybe someday. So then finally onto the river. Hydrokinetic energy, and there's different types. I'm not going to go in those details, but the point is these are something that, if and particularly now where they're talking, people are talking and dams are coming out and being breached and stuff, these may be one important way to replace some of that lost energy. So um, I'll say more about environmental impacts a little later, but the stressors are what can damage both the uh, the devices and also the biota, and uh, and so the receptors are, of course, not only the marine biota, but also the habitat and ecosystem dynamics. So I'll get it more into that later. There's just they on the slide is shown some examples of the type of damage that can be done. I'll have more to say about that a little later. But anyway, moving on. Um, as I said, this is still a developing field. We do not have any viable projects right now in Washington. There are proposals and there have been attempts, but we're still trying to get to that point. And the reason why emphasize the importance of spatial temporal planning is that you have to work around other types of ocean uses, fishing, recreation, shipping, etc. And in doing so, and also and of course, also the movements of the animals, including whales, fishes, etc., so that you're going to have to. you have to actually know about the biota to be able to figure out how to reduce impacts and make these projects more viable and and not having too many impacts. So as I've mentioned, this is tough work. The marine environment is very, you've got tsunamis to worry about, you've got rogue waves and everything else that you're going to have to make sure that you control for. You're not just building these for the average conditions. You have to build them for the worst conditions, and that does takes a lot of planning. So anyway, let's move on real quickly. I mean, this is not my focus of the talk, but the feds, through the Tethys website, which is associated with the federal government, has a lot of training materials that, particularly for younger ages, that students can look at, and not just for marine energy, but for a lot of other topics as well, seaweeds. I'm trying to think what else. There's all kinds of stuff. So anyway, that's that part of the talk, and let me stop sharing for a second and see if I can get to the other part again. Okay, let's see. Okay. Whoops. Uh-oh. Am I showing?
Not yet. So
Uh-oh.
if you go down to that share, you click on that, and then your application windows from those, if you pick the PowerPoint, it should be.
Yeah, for some reason I'm in full screen for my PowerPoint and I've got to figure out how to get out of it.
So
Sorry.
press escape. Escape from that. That'll get you to where you can get on Zoom.
No, that's not working. Shoot.
Mm, escape's not doing it.
Nope. We need another way.
Um,
I may have to, I don't want, if I, worse, end show. Let's try that. There we go.
yeah,
All
nice.
right. So let's,
And now if you
the
click on
share.
share
Yeah,
under application windows, PowerPoint should be one of
got it.
them.
There we go.
All right.
And slideshow. Is that working?
Give
Back
it.
to
Yep, you got it. You're good.
Okay, so you've already seen the title slide. Let's move on. That federal presentation that I just showed, the Hemery presentation, there's the citation for it, as well as the longer online report that information came from. So, um, and it also, if anybody wants copies of the presentation later, I'd be glad to share it. So for both. So,
And side note, Dr. Hemery is joining today, so
oh,
it's
well,
in the crowd and listening.
that's interesting. Yes, I took her course. Yes. All right. So anyway, is that showing? Do you see the whole slide on that? Yeah. Okay. Anyway, everything that's important is there anyway. So for in terms of the definitions that I mentioned a little bit about, of course, total energy includes brown, which is a non-renewable, and the green energy. Um, Brown energy has to do with types that require mining, which includes both fossil fuels and also nuclear because of uranium. And their troubles, of course, are they do have a lot of thermal and greenhouse emissions, and they tend to use a lot of water, which as climate change advances, water is becoming something that we need to be very concerned about. So now, in terms of green energy, it includes both inland and what we call the blue renewable energy, and blue, um, which is basically marine renewable energy, includes, as I've already mentioned, both the marine energy and the offshore wind farms. Marine energy, you have to take it a little bit, not totally literally, because it includes both river and marine hydrokinetic. And actually, from a federal standpoint, the Great Lakes are considered coastal. So even though, of course, it's freshwater. So, and then finally, as we've already mentioned that there's five types of marine hydrokinetic energy, which I'll say more about if time permits. The As I said, with population growth and climate change, alternate energy is becoming of higher need, and also with the spread of electric vehicles, which I, I prefer to use my manually powered bike for my errands. But anyway, but a lot of people are using them, and so we're probably going to start having brown and blackout problems in the future if we don't deal with this like other states are having. And I just put two artsy, kind of fartsy things there that have to do with when blackouts occur, the vampires tend to take over. So we don't want that, right? So anyway, with the let's start with the river hydrokinetic turbines. I already mentioned that they might help with as part of dam breaching operations. The big thing to realize what makes them different than dam turbines is these are bigger turbines. They're slower turning, which means less chance of hitting fish, etc. And they're also less densely packed. Think of it in two dimensions rather than one, where you're dealing with a dam that's basically basically a straight line, not exactly, but close. So there's a lot of ways to reduce the types of fish impacts and other marine biota because of this difference. Um, and now, as I mentioned, I deal with American Fisheries Society. We ended up coming up with two publications having to do with um, um, getting the AFS to approve that as a resolution as a way to help restore Pacific salmonids and help bring more food to the southern resident orca whales. So, and keep in mind that this as I said, I'm wearing my American Fisheries Society hat when I say that, not my DFW hat. So anyway, moving on to marine hydrokinetic power, which, as I said, is what DFW is focusing on. As I said, they typically have turbines, not always, but the tidal turbines as energy converters or techs are they're the best places here in Washington would be in the Salish Sea, particularly in narrower areas. Admiralty Admiralty Inlet has been explored. That there was even some talk about Tacoma Narrows, but that would be a tougher sell, I think. But anyway, we're narrow, faster areas, but too fast can be a problem. And they found that out in the Bay of Fundy back east where I grew up. And that is a place where they've had turbines, big turbines too. I mean, these big metal turbines that get destroyed by currents of 5 meters per second. So that's a little bit too fast for much of the technology, although I'll show a slide next of the hydro or Archimedes screw hydro turbines that probably would probably be able to withstand that. So that might be what the Canadians try next there. But in any case, in the old days, way back in 1986, the American Fisheries Society expressed a lot of concern about tidal barrages, and uh, and that was the technology back then. And those are basically saltwater dams, a little bit like we have for Capitol Lake, but with actual turbines. And so they they generate power, but there's it does change the environment a lot. And so these are very large scale projects, whereas a lot of what we're dealing with now are there's a lot smaller things. And one of the smallest kind of new technologies by eel energy is it actually undulates and creates energy, and not only being more eco-friendly, but can be put in a lot more places because, if you got a big turbine, you you're not going to be able to put it in too shallow water because it's going to be out of water, right? And that's not going to work for in a lot of ways. But these things are really small and probably can be put in a lot more places. So that may be one type of technology that who knows? Maybe that will be the one to commercialize first here. It's hard to say though. So here's the Archimedes screw turbine. Archimedes screws have been around for doing a lot of things for a long time, but they can also be used for marine and river hydrokinetic purposes potentially. So, moving on, a little more on tidal turbines. There's a win-win situation here where if the turbines are kept well maintained and are rotating efficiently and they're spaced properly, um, it can be good for both power production and eco-friendliness. And actually, I don't have time to go into the details, but if you space these things in ways where they riff off each other, kind of like in fish schools, where the fish, by being a certain distance apart, can actually reduce some of their swimming energy needs. And so it's a little bit like that. And so there's a win-win situation here where what's good for the industry can also be good for the fishes and other marine biota. Um, we've already mentioned about the greater tidal ranges up north, uh, the proposed projects in Washington many years ago. Snohomish PUD had tried in Admiralty Inlet to get tidal turbines, but they had cost overruns and they just, in the end, couldn't get the funding needed, and the feds didn't want to kick in extra money. So unfortunately, that didn't work out for financial reasons. More recently, there's been a Skagit Bay proposal, but the big mistake they made there, they didn't consult the Skagit area tribes, and the Northwest Indian Fisheries Commission put a stop to that real quickly, and I'll say more about the need for consultations later, but that's a big mistake in the present era. The little more success, might be on the outer coast. In Oregon, there's already a WEC testing facility. We could be doing similar things on our own outer coast, although we do have a marine sanctuary out there. So it might not be able to happen everywhere. But the testing facility off Newport in Oregon is working towards commercial production. They've been testing all these different types of wave converters, and uh, and so that's in the Pacific Northwest. That's the one uh, that has probably the best chance right now of going, becoming a fully commercial operation. Um, the A little more on the wave energy. It is more challenging technology because unlike tides, which tend to be pretty predictable, wave direction and velocity can be more stochastic, including the rogue waves. And I mentioned a Gordon Lightfoot song about the ship that was destroyed in the Great Lakes by a very big rogue wave. So, as I've already mentioned, they need strong joints. They tend to bend with the currents to produce energy, and they can be as simple as a point absorber, which is a power buoy, or as complex as I'll show in the next slide is the wave dragon. And this wave dragon, it basically gets water overtopping into it on its platform. And as you can see in the slide, it also can potentially even have wind power associated with it. The hydro turbines are in the middle in white there, which gives it its dragon name, right? And but in any case, the waves overtop into the reservoir that surrounds the turbines, and that generates energy. So that's one type of wave power. Moving on to offshore currents, I've already mentioned this here. It's not going to be here, but it could be elsewhere. The moving on to the thermal or salinity gradients. These gradients generate power through turbines, and um, we're not going to be doing, at least not anytime soon, the thermal gradient one, because that requires great differences between surface and deep waters. and the pipes bring up the cold water to the surface to create energy, and it's called OTEC power. And but the biggest problem for commercialization of that, and again, Florida and the Caribbean have been places where they've been looking at it in the United States and beyond. But the pipes for the warm and cold water pipes that are needed for this tend to be the limiting factor. And so who knows, maybe someday we'll get to commercialization, but not here in Washington. Salinity gradients is the least developed of all the five technologies. But salinity gradients, we know there's very good salinity gradients in estuaries like we have here. And so maybe someday we'll be able to harness that, but it may take a while. Moving on to the more related to the report that I'm working on for DFW. It was funded long ago by the CDOC Society when doctors Mark Hayes and Timothy Quinn headed it up. And in the last few years, they've both retired. And so, I've taken over that baton to try to see what we can do with it and get this to publication, hopefully. But as, as I said, I began a few years ago, and and mainly right now you know, one of the things we have with our agency right now is how much do we push the science versus how much the policy. It's controversial. Budget cuts are not helping for publication, but I am hopeful that maybe we can get there. And if anybody, particularly in academia, wants to partner with me on this, please let me know, and maybe we can help get things moving a little quicker here because I'd like to see if we're going to ever have marine hydrokinetic power and also river hydrokinetic in the state, we're going to have to start publishing stuff on it so people get used to the idea so that maybe we'll get away from a NIMBY approach and people will start saying, well, this is better than fossil fuels if we can do these right, and there are ways to do these projects right. So uh, anyway, so as I said, there's a little bit of tug and war, and the Ruckle House Center did publish a little bit on that, but hopefully we can get to a point where um, both science and policy issues can be presented. I think they should be done separately, like we did for our riparian PHS project, and that way both policy experts and scientists can focus where they're good at. So we'll see what happens with that. Anyway, uh, if anybody wants to collaborate, you could certainly let me know. This is the main report, which I ended up changing one word for it because I wanted the emphasis to be on projects rather than devices, because it's not just typically it's not just putting one device out there. It's typically an array of devices that need to be spread out in an optimal way, as I already mentioned, and also needs to make sure that it's not interfering with whale, fish migrations, boating, etc. So the we have sections of the report, and here they are. First one, water quality circulation, pollution from biofouling materials. Unfortunately, if for anybody who's worked in the marine environment or just has a boat, that animal and plants will attach to them and use that as their habitat. And and eventually, if they build up enough, they reduce efficiency, and particularly for marine hydrokinetic, where efficiency is good for both energy production and for reducing biotic impacts. And I'll say a little more about the latter in a second. But it's there. you will need to do some anti-biofouling, and there are some ways that are less toxic than others, and we talk about that in the report. Physical barriers to movement, again, optimal placement, making sure that you're not stick right in the middle of a popular whale migration route, for example. So these things have to be thought about. The propeller type turbine impacts, as I already mentioned, these typically you're not going to have fish hitting these like you do with the dams and getting cut up. Um, the evidence is showing that um, fish and wildlife tend to avoid getting hit, but that um, but but nevertheless, we do have a section on mechanical injuries that are associated, and not only includes impacts but also entanglement and getting, for example, entangled in a cable. One way to reduce that problem is to bury the cables, but that does cost more. But that is also good for reducing other problems that are associated with cables, and which I'll come to in a second, which are the electromagnetic fields that they project. Though that may not be a big problem, it's still something that could be reduced by underground cabling. But in any case, probably the more important part of what the turbines can create are cavitation and then the other fluid forces. And cavitation is basically water explosions, kind of like having a bomb in the water. Um, and uh, and if turbines are running inefficiently, um, particularly if they get too much biofouling on them, um, or just are not being maintained properly, they start producing bubbles in the water, and bubbles can lead to explosions. So we won't get too more technical in that, but those are things you want to keep to a minimum with efficient running devices. Um, Moving on to, I did mention electromagnetic field impacts, EMFs. Um, Probably not the biggest problem for the marine hydrokinetic energy, but nevertheless, something that probably needs more study. What studies have shown is that fishes that are tend to be more sensitive, like sharks, which have an electric um, or anything, other types of fishes like electric eels and stuff, you that may have that may be a little more sensitive. The tests that have been done so far show that the fish know those fields are there and they may orient a little differently, but um, it's not clear that that is going to totally throw things off. But so my department and the feds will have to figure out, whether how important it is to bury the cables, and what does, as I mentioned, cost more money. Moving on, the structures can affect benthic habitats if they're anchored to the bottom, which many are. There's other types that use floating platforms, and that's a little different. But even floating platforms can cause shade, and that shade could also affect fish and wildlife. And so those need consideration. And finally, dealing with the cumulative aspect of impacts. Are all these different other stressors? Do they act independently? Are there synergistic problems, or is it a linear thing, or does some of these impacts cancel each other out in antagonistic form? We really don't know at this point. But the but moving on, the if in Washington, where TEC or WEC arrays are probably most likely to happen, if it's going to happen at all, they basically become de facto marine reserves where, you know, for public safety, you're not going to have fishing in there. The devices themselves, a lot like oil platforms do, provide fish cover and and may actually be a benefit in some regards. And as well as with all, that's true of offshore wind farms as well. And the big question will be is what buffer sizes should be around Marine-Hydrokinetic arrays or wind farm for that matter, because the bigger you make them, the more that you keep people away from the resource. And so it's an issue that's going to have to be figured out, try to optimize public safety versus being able to allow other people to recreate and whatever else out in the ocean and other industries, et cetera. So that's something that's a real important. Finally, it's very important for these projects to deal with the local stakeholders. I already mentioned tribal, but other anglers and other types of recreationists, surfers, and whoever, they all need to be consulted if everybody's going to be happy to see these things move forward and not do the NIMBY thing. So, um, here's the titles of the other two chapters, which are a little bit are lesser priority right now for what we're working on at DFW. The one on the energy devices focuses on all five device types, but particularly on the TEX and WEX. And both of them, there's so many different types that are out there that it's definitely there's definitely a lot of variety there. Finally, for the target biota chapter, um, that's dealing with particular species rather than, sort of fish in general or marine mammals. It's a little more species specific as to where spatially, temporally they're hanging out, so that we have a better idea of where these uh, hydro marine hydrokinetic arrays might occur. And so, and we picked a species list that was based particularly on imperiled species, but also others of trophic food web importance, foundation species being ones, such as forage fishes that provide for the food webs, keystone species being something like the sea otter, for example, that can affect how much kelp, how well kelp beds are doing because they eat the sea urchins that tend to mess with them. So things like that. Almost done here. And we already talked about how the hydrokinetic power can diversify the energy portfolio. Hopefully, project approvals can be done in a balanced fashion to reduce the problems of bankruptcies or switching to other types of power production. We want to actually see companies, if this is going to become viable, companies be able to make it through the process. Um, there's even there's even been accusations from this industry that the fossil fuel industry is using the NEPA process to try to keep marine hydrokinetic projects from happening, which is a bit ironic since that uh, they don't tend to like NEPA, but they seem to be using it as a weapon to some extent. But anyway, but one way that these projects might be able to be more financially stable and being eco-friendly is through financial processes that I mentioned there. I won't go into detail on that. It's actually now being addressed federally for hydropower dams because, if something goes wrong, are there funds to try to fix it and reduce biotic impacts instead of, just so it suddenly being a big surprise that becomes a big disaster like that. So there may be ways to help make projects more you know, people are more likely to approve of what's happening if they know that there's funding if something goes wrong and that adaptive management can happen as needed. Finally, a little bit on the government parts of the process. My agency, through the hydraulic permit approval process, um, for the marine renewable energy, um, the big the big focus is near shore, but also for cabling that has to come inshore. So these are areas where the state will tend to focus on. The feds will tend to focus on the offshore areas a little more, and in so doing, through two agencies, FERC, which also deals with hydropower dams, and the relatively new Bureau of Ocean Energy Management, which was a stepchild, one of the stepchilds of the Marine Mineral Service. So, which basically happened after the Horizon oil spill. The finally, and this is my last slide, by the way. Um, I'm guest editing right now a special issue for the Habitat program that I work for. New conservation strategies for freshwater and marine fishes. Habitat is the key, and but we're very interested in both habitat and fish passage issues. Uh, and so if anybody has a paper on anything to do with blue energy impacts in general, fresh or saltwater, you are welcome to submit something. And we have an anchor paper that me and some colleagues from Washington and Oregon are working on that does talk a little bit about marine hydrokinetic, or well, both marine and river hydrokinetic energy, and as well as many other cumulative impacts, or used to be called the 4-H impacts, but we have decided, particularly with the proliferation of exotic chemicals and noises that can pervade the marine and freshwater environment, as well as exotic species, that we we are proposing more H's than four plus. But in any case, the ultimate goal is to how do we get to how do we get to viable projects, and to do that, we have to know what these impacts are. So feel free to submit or talk to me about it if you think you might have something to submit. And with that, I think we have time for questions. Yeah.
All right. Well, thank you so much, Dr. Vadas, for that. It kind of seems as though the potential is counterbalanced by the number of different obstacles and considerations that go into it. So, definitely a good summary as to the different considerations to bring into it. So, we'll pop into some of the questions. I'm going to start off with one that was submitted before by Terry, who is in the crowd for right now. And um, twice you mentioned overcoming NIMBY. So I wanted to reference this question as it relates to the Rosario Strait. So this is, how familiar are you with the proposed marine turbines to be located in Rosario Strait? What data can you share regarding the mitigation strategies, since the Rosario Strait is part of the critical habitat for the killer whales? And there are there also other endangered or threatened species in these waters?
Um, well, of course there are. I know that the proposal has occurred. We do talk not specifically about that project in our main report, but one thing to keep in mind is where the where the organisms are migrating. Typically, young salmonids are migrating along the shorelines, and therefore, if these projects are out in the middle, that may be less of a problem for them. On the other hand, marine mammals might be out in the middle a little more, but maybe not in the fastest places where these, like for example, tidal turbines would go. And so there may be ways to work around that. And I will have to get more familiar with the Rosario project. But as in a general sense, um, I do think that, you know, organisms don't like the fastest waters because that means they waste a lot of energy trying to swim in it. And so, but that is where you want the turbines. So I think there may be ways to work around that. And particularly for the young salmonids migrating along the shorelines, adult salmonids may not be so tied to the shore, but still, I don't, I don't they're not going to be migrating out in the middle in the fastest currents. It's too tough for them, and they need to get back to spawn, not waste all their energy because they're not feeding anymore. So I think it can be worked around, but again, I'll probably have more to say on later as I get caught up on that project. Yeah.
Gotcha. Cool.
Yep.
Well, thank you for that. And then we've got another one in the Q&A that says, could you speak on how you see algae and seaweed in the water column affecting the propellers, say, of some of these devices? Has this emerged as a significant problem in testing?
Um, the the different devices are some are better than others at debris control, and not just seaweeds, but debris in general. And because there are a lot of things that get in the water and all. And and on one in the back burner chapter on the energy devices, we actually talk about some of the which devices actually repel debris better than others. So it really depends on which device you're talking about. And but yes, those can be problems. One thing for marine hydrokinetic projects in general is that you can't just put them in and leave and just say we'll come back in 5 years. No, you're going to need to do maintenance, make sure that things aren't getting stuck in there. It's probably a little bit like happens with oil platforms. Maybe you need somebody who stays out there to kind of be the caretaker, or if not that, at least have boats come every once in a while. But you don't want to have too many boats coming because they cause impacts too because of collisions with whales, et cetera. So, trying to figure out those kind of things, they'll have to figure out how much do you want to have on-site maintenance versus periodic maintenance. And so, but, um, in a general sense, some devices are better at it than others, and maybe those are the ones that will become more commercially viable. So I'll leave it at
Gotcha.
that. Yeah.
And I think using that as a springboard, we do have a question that's about a particular project, knowing if there are any updates that you know about the Opalco project. But I want to wrap that into another question at kind of a larger scope is at the beginning, you had mentioned that there is a potential, given with the previous administration saying 20%, give or
Mhm.
take, of the energy that this could provide.
Yeah. Mhm.
Where do we stand on that regard? Kind of relating back to the very first talk that we had on this, it seemed like a lot of experimentation, a lot of possibility, very little in the way of traction. Where are we in the trajectory in the arc on things?
Commercialization has been tough. I mean, it actually looked like, as I mentioned, with the East River in New York City, that tidal turbine project was going to go through. It withstood Hurricane Sandy. It and I talked to the CEO of that company who was dealing with it, Verdant Power, and he was going like gangbusters to commercialize it. At the last minute, they decommissioned they decommissioned it, and and then they said we consider that a success. And I'm like, well, isn't success actually having it go for many years of commercialization? And rather than, I think it was less than 1 year. And it was like, yeah, so I think Eurasia has done a better, well, they have done a better job at this for whatever reason with the way their laws work, and that they've been able to, and maybe that's because of less competition from the fossil fuel industry or whatever. I think that's a real significant problem in North America. And um, somehow we got to get to a point, I think, in my opinion, would be we got to look at this like the space race that once happened in the 1960s. We got to actually just say, you know, we're going to do this. Even if it's hard, we're going to do this, and we're going to make it happen. We're going to, figure out which are the best technologies that benefit both energy production and reduce the biotic impacts, and put some funding into it. You know, I just, you know, we, there's a lot of things that get subsidized in this country that I don't necessarily agree with. And we we have to have a different thinking. And I don't know. I mean, I'm not a political scientist by any means, but it does seem like we have to have some sort of paradigm shift in thinking, and that we actually have something that can receive bipartisan support as a way for people, as these things could be job creators, and that we got to get away from, the fossil fuel thinking on everything, because, to build these projects requires fossil fuel in many cases, for the most part. If we waste all our if we run out of fossil fuels before we build all these projects as alternatives, we're going to be really screwed, in my opinion. So I think we got to start allocating resources to the future and actually, sorry, I'm a little bit on my soapbox here, but we really have to be thinking of the future generations, like the seventh generation approach of the tribes, in that if we really care about our kids and grandkids and so on, we've got to start thinking differently and not, it was, Japan was once, I think thinking is a little bit different after Fukushima, but before that, their business model was towards the long term, not necessarily making money in the next year, but what's going to make us money 10 years or 20 years down the line. And so we just have to have a little bit of a longer term thinking. And that's my opinion as a scientist who may be a little naive on some of these things. So, yeah.
Well, I think there is probably an element of naivete that's going to be needed to get some of these projects at the scale, scope, and reach that we need them to. And there was something that you just talked about in terms of the seventh generation, and
Mhm.
wanted to loop back. We have Heather, who's in the crowd, and she works with the Swinomish tribe.
Mhm.
And basically, she offered a perspective that is now available in the Q&A that's saying the Rosario Strait and the Opalco project are the same, and kind of touching on
Yeah.
what you already mentioned, that there was n no communication whatsoever within that process. And you mentioned how in this day and age, or ever,
Yeah.
like that is
Mhm.
basically an unacceptable approach. Can you talk a little bit more about the levers that we can pull for a collaborative way of thinking, of communication, and still moving forward on some of these things, or finding a way that is not simply, well, this works best, sorry to those who are suffering. So I think that, if you can comment on some of that spirit of collaboration. I think there are a number of folks who are affiliated with the tribes who are here today, so that might be of help.
Yeah. Well, I mean, my first 15 years at DFW, I was working on, watershed planning, and which was more of an inland kind of process, for different water resource inventory areas. But and that included up north in Whatcom County, by the way. But the hmm, I think we kind of almost need a process like that again to deal with energies, both river and marine hydrokinetic, where the local stakeholders come together, they work through the problems, get their issues heard and addressed as best be, and we come up with win-win solutions. And um, I've won AFS, American Fisheries Society awards because I think I'm somebody who through that watershed planning process learned how to come up with these kind of things, which it may not be the best for any one group, but it's something everybody can live with. And those are the type things that we probably are going to have to work towards. So that we have actually a formal kind of consultation process that does, like I said, bring all the stakeholders in, and the tribes, other anglers, surfers, other types of recreational boating, sailing, for example. I mean, whoever is going to be on the water needs to be part of this process. And so I think the state's going to have to take some initiative on this. I I think the watershed planning process was a good approach that should be brought back in a different way now, thinking more about energy. So that's my suggestion anyway. So yeah.
Yeah, and I think you're right that there is historical precedent, particularly say with Billy Frank Jr. and how
Mhm.
agreement has been reached, but to have just one example as a precedent is good, but without having the structure for continued conversation. And I think that's where they would probably run into a lot of discord and friction. And I think this is part of the bigger conversation around energy sovereignty, land use, stewardship, and multiple competing purposes that end up making for a lot of roadblocks where now the status quo then has room to continue to propagate and be the default as opposed to being able to pivot. So it's thorny, it's not easy, and I think your point around compromise and getting all voices to the table is the start, but even from there it ends up being quite difficult without that scaffolding in place.
Yeah, I think the state will, and I mean that which basically comes down to the governor's office, if I may be so bold to say that they really have to put some initiative into this because tribes need to be consulted. It's so 20th century to think otherwise. So, so yeah,
Mhm.
it's and all the other stakeholders too, so that we don't have the NIMBY thing. I mean, a lot of island communities, for example, are concerned that, oh well, if we let this in, we're gonna we're gonna lose our rural atmosphere. And so how do you make sure that they don't? Because I grew up in a rural area. It's those are nice places to grow up, and to live, and you don't necessarily want to become like Seattle, for example. Um so these concerns have to be dealt with so that people can feel confident. Okay, if we bring in this power, maybe this is going to help us become self-reliant. Microgrids might reduce our energy bills. We don't have to depend on BPA anymore. And maybe we'll have more control over it, and as long as people need some ways for people to buy into things, they have to feel some ownership for it. So getting them formally involved in the process and making them part of the team has to be done. And I, that's something that I don't have in my report right now, but it's making me think that maybe I need to have something about it in there. So yeah, yeah, that's a very good question. I think it's possible, but people are going to need to be educated about it. If they don't know something, they're going to fear it. And my hope is that between what I'm doing and that what others are doing, we can get this information out there so that people will start feeling a little more comfortable and not just say this is some unknown technology that could totally screw us over. And I don't necessarily think that's the case. So yeah.
Yeah, it definitely seems like an opportunity both to a a kind of highlight a familiarity that combats NIMBY for a
Yeah.
community, but also if you the inclusion of how does this communication and this channel open up, it also kind of shows like this is not an afterthought in the planning
Mhm.
process. So
Yeah.
inclusion in the report, it might be a worthy inclusion. So yeah, thank you for the expansion on that answer. I appreciate that.
Yeah. And one thing that the state might even be able to do would be to have like a formal checklist process where these are the things you need to do before we're even going to consider you testing turbines in Skagit Bay, for example, and that if you haven't checked off the tribal box and also the other local stakeholders, it's a no-go, so that yeah, there's probably a way to do this. And again, as a scientist, I'm probably a little naive on how that works, but it seems like a checklist might help. Yeah.
Yeah, and from the start. So no, I think that is the other part about how we're so hyper specialized. It's hard to bring all those voices in
Mhm.
a balanced way that's not so far along the process that our ability to pivot is sacrificed. So uh, we have one follow-up to one of the things that basically is about micro and macro grids. So can you
Okay.
speak a little bit about basically the distinction between micro and macro grids? And the follow-up is Texas is not part of the national grid and suffered quite a bit a few years ago during the unexpected winter weather.
Yep.
Uh, can microgrids ensure that they are more stable?
It could. Yeah. I mean, and of course, in our region, the big macro grid, of course, is the BPA with the Columbia Snake River dams. And but if we start having brown or blackouts, the cities are probably going to get more priority for keeping the energy going, than the rural areas. And so, and you even see it during power outages here. Me, who lives within the city limits of Olympia, I don't tend to lose power like my friends out in the sticks, right? They can lose it for days. And so there is a big difference there. If microgrids can develop, where the citizens have a little more control over the process, I guess I would think through the PUD system, I would, is I guess my sort of maybe naive answer, but it seems like through the PUDs, possibly you could get these set up and where the city, I would think that it would require citizens to have meetings to make with the people running these operations and make sure that they're going to work for their purposes. It's not going to be too loud at night, or it's not going to, uh, it's not going to impact, them in ways like, now you're telling me I can't fish there anymore, and people are or hunt there anymore, so people are going to need to know what they lose and what they gain. And it has to be a very transparent process so that people, like I said, it's probably not going to be optimal for everybody, but what can people live with? And the only way that is to be very transparent about what potential impacts there are and how they can be mitigated. And citizens as well as scientists and politicians and everybody probably has ideas that might contribute to reducing impacts. And more heads are better than one is my way of looking at it. Yeah.
Yeah, I one of the things that comes to mind, and I even said this during last speaker series, is that
Mhm.
there's no such thing as a free lunch. Like in order to
Mhm.
modulate something, to pull a lever on something, there is going to be some form of impact on somebody somewhere. And
Yep.
one of the things that you probably have some insight into with the consideration of all of these different things is, I mean, it's the trope that things that are moving on the administrative state or governmental level is typically very slow because of all these, while it somehow seems as though many private industry doesn't necessarily have those same impediments on things. So
Mhm.
is there a quick commentary on like
Mhm.
how to enact projects in a way that is both considerate and inclusive of voices while also not getting stuck in gridlock? And I know that's a bit of a
Yeah.
humdinger, but it's one that I think is going to be more and more salient as time goes on.
Well, from the state point of view, the hydraulic permit approval process is the big way to deal with these things. But there is nothing that, although it deals with other things like um, culverts and other types of in-stream projects, um, this whole thing about hydrokinetic power is a new thing for the agency, my agency, and so they're I think they're going to have to figure it out. The people who are dealing with that will have to figure that out as they go, as to how strict they're going to be and what kind of guidelines they're going to provide. This policy issues for hydrokinetic power are developing as we speak at DFW, and people are trying to figure out where they fit in the process and everything else. So there's going to be a learning curve here. As I've already mentioned, the federal process a little bit. It is a little bit arduous, and you know, um, and uh, and and I think that's the big difference from us from Europe or Eurasia, where these projects are more common, is those governments have been more. welcoming for that because I think they're looking at the bigger picture better is we got to deal with this climate change problem or it's going to deal with us. And so, um, and I just think they're just more progressive. And I think if we're gonna do this, we're gonna have to say, if we deny a project, we're basically saying, status quo fossil fuels is okay. And I think we have to get away from that thinking and realize that we got to get to a better place. It may not be perfect, but can we at least do something that's going to reduce greenhouse emissions, um, and reduce impacts? And as I said, the river and marine hydrokinetic has a lot of potential. The turbines do not kill fish like they do for dams, and so we really should give these things more thought. So, yeah. Hmm.
And the end of that question actually lends itself quite well to one from one of our students in the course and says, do you think that the marine hydrokinetic development can lead to a reduction in the existing river hydrokinetic infrastructure?
Wait, say that a question again. I'm not sure.
Do you think that the MHK development could lead to a reduction in existing RHK infrastructure?
Yeah, well, I'm not sure we've got a great RHK structure yet. It's been talked about in the Columbia River, but it's possible. I mean, and that's me as a scientist. That's not really some question that I might answer per se, as much as to say that, except that if dams come out, you might need something to replace that. And if river hydrokinetic is available, maybe people are more likely to improve, for example, the lower Snake River dams coming out because they realize, okay, we're still going to have power. We're not going to be in the dark tomorrow, and so I so I don't, yeah, I'm not going to put down river hydrokinetic and say marine will do it all. Marine can, marine certainly can do it, particularly for coastal communities if they want to set up microgrids. I don't, I'm not a energy expert who could say how the grids should all be connected and all that kind of stuff, but I mean, they can be connected to the macro grid too, but if local communities are doing this, I think it's more to their benefit to set up microgrids because then they're going to be first priority, not last priority. So, but again, it really depends on how big scale the projects become. The more megawatts you can produce, the more likely something is going to be that could be connected to a macro grid. Um, and I'm not sure I'm totally answering the question.
I think you touched on it. Yeah,
Yeah.
there might have been a bit of confusion in the question on whether RHK represents the existing dam infrastructure, which I think you touched on.
No,
Yeah, that
no,
is
no,
a
no.
separate
See,
thing.
with if you just have the um turbines in the water. They're in the water themselves. They're not associated with the dam. There's no blockage of fish migrations except, the fish are probably going to skirt around these hydroturbines and, they can detect the currents, the weird currents. They tend to stay away from that turbulence. And so they're going to go around it, but at least they can go around it. Whereas a dam, they're going to need to depend on a fishway if one exists at a dam, and not all old dams have fishways, and not all fishways work well. And even if a fishway works well, like in the lower Columbia River, for example, you got the exotic American shad blocking the fishways, making it harder for native species to get through. So, you have all these other problems that you do not have with hydrokinetic. So please realize that the river hydrokinetic is independent of the hydropower dams. They're two different things. They both involve turbines, but the river hydrokinetic is not associated with dams at all. So,
Gotcha.
yeah.
Well, thanks for the clarification on that. Thank you so
Yep.
much for all of the perspectives that you brought. I like the direction that you have kind of brought so many different perspectives into view on this. And that is all that we have time for. So thank you, everybody,
Yep.
for the questions. Thank you so much for your time, your preparation, and all the work that you're doing in this space. So we really appreciate it.
Thank you. Appreciate being able to update everybody on what we're up to. Yeah.
Cool. All right. Well, thank you everybody for the last edition of Energy Speaker Series for this quarter. We will see you in the fall.
All right.